Welcome. We begin our journey with logarithmic functions, right? Introduction to logarithmic functions. Well, to get started here, I kind of wrote an equation, y is equal to 10 to the x. And I'm asking you, I'm begging you, can you solve this problem? 25 is equal to 10 to the x. Well, I'm basically asking you 10 raised to what power is 25? And this becomes increasingly difficult to do because right away, 10 squared is, I'll write it like this for you. 10 squared is 10 times 10, which is 100. So clearly, this is going to be some decimal answer, right? It's going to be 10 raised to some power that's less than 2, but bigger than 1. I don't know, 1 point something to get me 25. And without logarithms, we are not going to be able to solve a problem like this, right? So kind of to get started here, whenever you want to find the inverse of a point, well, what do? Well, you flip the x and y. So let's go ahead and let's, plug in. So let's say we got, let me just erase this over here. Let's say we get f of x is equal to 10 to the x. I'll write it like that. And let's plug in 2. And so we get 10 squared, which is equal to 100. Let's plug in 3. 10 to the third is going to give me 1,000. And one that I should have done this right over here, f to the 1. 10 to the 1 power is 10, right? And last but not least, let's plug in 0. 10 to the 0, well, 10 to the 0 is 1. That's just because the 0 exponent just means 10 divided by 10, which is 1, right? So we got a couple points here. Let me go ahead and write some of these down. We got a 0, 1, this from this right here. Okay, we got 2, 100. 3, 1000, right? So if we were to go to graph this, let's put an x and y table here, x and y axis I meant. We basically have 0, 1, which is right there, 0, 1. Okay, we got 2, 100, which is like all the way up here. And we got 3, I'm gonna say 1000. Obviously this is not drawn to scale, right? And we got something that looks something like that, and this is going to go and look something like this. All right, now that we have this here, well, to find the inverse, we've basically flip our points, right? So to find the inverse, it's 1, 0, 100, 2, and 3, 1000, right? It's gonna be 1000, 3. All right, so I'll start off with 1, 0. Well, 1, 0 is right there, and 2, 100. So all the way over here, 102, which is somewhere over here. And obviously I have to extend this. 3, 1000, 1000, 3, 1000, 3. Obviously it's not going to be perfectly drawn to scale, but we get something that looks like that, my friends. Oops, not the best drawn graph here, but you kind of get the idea. Okay, and you can see that this is a reflection over the y is equal to x line, which tells us that these obviously they're inverses of each other, right? Well, we want to be able to get a function, some equation that models this green line, and it turns out in math we decided to call this function here the inverse of y equals 10 to the x. We call it let me use a different color. We use y is equal to log of x. All right, so let's go ahead and look at this real quickly. Here's my graphing calculator. Let's go ahead and plug in, okay, y is equal to 10 to the x. All right, and let's plug in log, which is right over here, log of x. And you're going to see that we're going to basically get the exact same thing that we kind of drew right over here, right? There it is, y is equal to 10 to the x, and y is equal to the function we were looking at. Let me go ahead and basically, let me just do something like this real quick. Let's go ahead and zoom in ever so slightly, all right? So we go ahead and zoom in somewhere right there. and you can kind of maybe see a better image. There is up the point 0, 1, which is right there, and there's the point 1, 0, and you can kind of see that these in fact here are inverses of each other, right? So the idea is y is equal to 10 to the x and y is equal to log of x. These are in fact inverses of each other, all right? And this is going to help us solve the proposed problem up above, which I'll show you in the next video. Now, one thing to keep in mind is you'll notice this is the inverse of 10 to the x, and it's kind of like our standard log, right? So there's kind of like an invisible 10 there. For example, if we had y is equal to 2 to the x, well, the inverse of that would be log of x. Well, again, now because it's a 2, we have to put a little 2 there, right? Let's say we had y is equal to 3 to the x. Well, this would be y is equal to log base 3 of x. And these will be this tells me they are inverses of each other. That's how we define it in mathematics, all right? So pretty much anytime we have any function, 3 to the x of some sort, or 4 to the x, y is equal to 4 to the x, my inverse is going to be log base 4 of x, right? But anytime you don't see it, anytime it just says log of x, we assume that there is this invisible 10 right there, and that means that it's just the inverse for 10 to the x. All right, perfect. All right, well, that's just a quick introduction on logarithms. They're just inverses. These are inverses, inverse of exponential functions. Okay, that's what a logarithm is, and they're going to be so useful for us as we continue on our journey in these videos. Thank you very much for listening on point, my